Steps to create a large language model. www.innovatingbusinesswithoistrategics.com. The first step to create a large language model is to gather a vast amount of diverse and high-quality training data. The next step is to pre-process the training data to clean and format it in a way that can be effectively used for training. This includes tokenization, lowercasing, removing stop words and punctuation, and converting text into numerical representations like word embeddings. After pre-processing the data, the next step is to choose a suitable architecture for your language model. This could involve selecting from existing architectures like recurrent neural networks, RNNs, transformer models, or a combination of both. Additionally, you may need to determine the specific modifications and hyperparameters that best fit your use case and desired performance. Once the architecture is chosen, the next step is to train the language model using the pre-processed data. This involves feeding the data into the model, optimizing the model's parameters through techniques like backpropagation and gradient descent, and iterating this process over multiple epochs until the model achieves the desired level of performance. Once the language model has been trained, the next step is to fine-tune it for a specific task or domain. This involves continuing the training process on a smaller dataset that is specific to the target task or domain. Fine-tuning allows the model to learn task-specific patterns and improve its performance on that particular task. After fine-tuning the language model, the next step is to evaluate its performance on a validation or test dataset. This evaluation helps assess how well the model is performing in terms of metrics like accuracy, precision, recall, or any other relevant evaluation metric for the specific task at hand. Based on the evaluation results, adjustments can be made to further optimize and improve the model's performance if needed. Once the language model has been optimized and its performance is satisfactory, the next step is to deploy it for inference on real-world data. This can involve integrating the model into an application or system that requires natural language processing capabilities, ensuring that the model can handle a range of inputs and outputs efficiently and accurately. Additionally, monitoring and maintenance of the deployed model may be required to ensure it continues to perform well over time. The next step after deploying the language model is to monitor its performance and gather feedback from users or other sources. This feedback can help identify any issues or areas for improvement, such as handling specific edge cases or addressing common user queries. Continuous monitoring allows for iterative improvements to the language model, ensuring that it remains effective and up-to-date in its ability to understand and generate natural language responses. The next step after deploying the language model is to monitor its performance and gather feedback from users or other sources. This feedback can help identify any issues or areas for improvement, such as handling specific edge cases or addressing common user queries. Continuous monitoring allows for iterative improvements to the language model, ensuring that it remains effective and up-to-date in its ability to understand and generate natural language responses. In natural language processing, one common approach is to use pre-trained language models, such as BERT or GPT. These models are trained on large amounts of text data and learn to generate meaningful responses based on context. They can be fine-tuned for specific tasks to improve their performance. Additionally, techniques like tokenization, part-of-speech tagging, named entity recognition, and syntactic parsing are commonly used to process and understand natural language text. When it comes to natural language processing, machine learning is often used as a core approach for training models to understand and generate language. Other techniques such as rule-based systems and handcrafted grammars can also be used, but these approaches tend to be less flexible and more time-consuming. Machine learning techniques allow for the development of models that can learn from data and adapt to new contexts, resulting in more accurate and effective natural language processing.